Hello, can you hear me?
Yes.
Okay, can see textbook. Textbook.
Yes, teacher.
Okay. Come. For the previous chapters, chapter 4, permutation, combinations. Any question you want to ask before we continue with new chapters?
No.
No. Oh, means good lah. You can do very good. Okay. Can we change book? Chapter 4, you are using which book?
AM1.
AM1. I think if you don't come back to school your AM1, AM2, AM3 I think all will be finishing. Okay, so this change to second book. Okay, random variable. Chapter 4, you're using MX1 so now this one using at MX2 If already the book finished, then you just use test pad or any test pad, just put together with the book lah. Okay, staple the whole stack or whatever lah in the book lah. Okay, when ready can go back to the school, only go and buy book some more lor. Okay, but when you go back to the school, I think we have finished the syllabus, then you don't need to buy book already. Yeah, when we do revisions, we do partial or whatever, mostly we are using paper already. Well, we no more using book lah. Okay, like these current situations, don't tell your parents go back to school. I don't think the bookshop is open also. Don't tell your parents to go back to school to go and buy long book for you. Okay, no. Okay. Okay, so for these chapters, we're going to learn. Okay, actually the title of these chapters is probability distribution. Okay, so under this probability distribution, we're going to do two types of distribution. One, we name it binomial distributions, and the second one is a normal distribution. Okay, binomial distribution actually is a type of distributions. We call it discrete distribution. Okay, so for these chapters are a few new words, new terms that you're going to learn. At first you'll blah blah lah, don't know what and what, but slowly I will introduce to you what is the meaning of the terms means lah. Okay, and then for normal distribution actually is a continuous distribution. So these two distribution are different. One is discrete, one is continuous. Okay, actually by today, okay, when you finish the lesson, you should able to differentiate what is the meaning of discrete and what is the meaning of continuous distributions. Okay, so today it just introduced for you on all these terms okay, and by using the example. So when you really go into the binomial and the normal distribution, you will be more okay for it. Okay, so first of all, we look at this. What is the meaning of a random variable? Okay. Okay, you can look at this paragraph. Okay, you have two matches, two games. Okay, you play a games, okay, the result can be win, the result can be lose, or the result can be draw. Okay, and then you playing for two games, so okay, you can have a first game you win, second game you win. The first in the sample space, the first one WW stand for the first game you win, the second games you win also. For the second sample, first game you win, the second games you lose. Okay, this is the meaning. Okay, if you want to draw the tree diagram, also can. Okay, I draw out for you tree diagram. Okay, first and then the second. Long time didn't do a probability, then this help you to recall, huh? Okay, so first game it can be win, lose, draw. Okay, then every of these, okay, 3 bunches, win, lose, draw. Okay, same as this, and then same as this. Okay, therefore the first outcome will be WW, then WL, then WD. Okay, this is the first tree. Okay, then continue with the LW, LL, and then LD. LW, LL, and LD. Okay, this is from the second one, and then the third one is from here. Okay, so altogether 9. Okay, if we ask NS, still remember number of sample space, this one is 9. Okay, continue. If we only consider the number of win in the 2 matches played, okay, what is the meaning of this? Okay, this one is very important, we consider the number of win, okay, in the 2 matches played. Okay, then the number of times of winning can be none, once, or twice. Okay, what's the meaning? We see this. Okay, if your outcome is WW, means you win 2 times. So the number of win is 2. This is the meaning. Okay, if you LL or the DD, okay, all this no win, no W at all. This, and this. No matter you are lose or you are draw, okay, number of win is 0. Okay, then number of win is 1, is this one. Only 1 W. Okay, the other game is either draw, if not loss. Okay, so 1, 2, 3, 4. There are 4 outcomes. Have a number of win is 1. So you see a bit spatial, for this this topic. Okay, so always you got to see what they want actually, the number of win. Okay, so in this case, if you are playing 2 matches or the 2 games, the number of win, it can be 0, 1, or 2. This is very important. Once you understand this, the rest I think is okay. Okay. You see, it can represent by 0, 1, or 2. What's the meaning? This is the number of win. Okay. So you see, this is the random variable. This one we call. Okay. Set 0, 1, 2 is an example of a random variable. Okay, those value cannot be determined by okay, this one we don't care. Okay, so you have to understand what is the random variable. Okay, random variable is a variable with a numeric value. Okay, so inside this set is all number that can be determined from a random phenomena. Okay, so this one you can copy as a notes. Okay, remember this is very important. It's a numeric value. Okay, maybe you still not really understand the whole thing. Okay, we go through this. Okay, before this example, we see this, and a random variable can be represented by X, capital letter X, and value of the random variable can be represented by the R. Okay, so remember this X is a set now. X is equal to 0, 1, 2. Okay, it's a set. Okay, the R is the number inside the set. Okay, from the above situation, the random variable X for the number of win can be written in the set notation. Okay, we look. Okay, state the random variable for each of the following situation. Okay, a die is thrown once. Okay, what is the result that you can see? Okay, remember random variable is how to say? It must be a numeric value. Okay, so you throw a dice. It's either you can see 1, 2, 3, 4, 5, or 6. Okay, so the random variable is the number on the top surface of the dice. Okay, so in the set notation, you can list out 1 until 6. Okay. The other example, a man is waiting for a bus at the bus stop. Okay, so the random variable here will be the length of the time spent at the bus stop. Okay, this one will be a inequality. Okay, after we will see in detail. Okay, how we write out. We go through straight away this one. This one got mistake because this one it will not give you a numeric value. Okay, so this one you can throw this question away. Okay, the result of the Malaysian football team in SEA Games, this one is a win, okay, loss or draw. Okay, so this is not numeric. Okay, so this question is not random variable. Okay, this one wrong. Okay, we look at B, the number of white cars among 5 cars in the parking lot. Okay, state the random variable for each of the following situation in the set notation. They want it in the set notation. Okay, so I put set notation. Okay, so you got in the parking lot you got 5 cars. Okay, so what is the possible that the number of the white car appear? Okay, it can be no white car at all, so 0. It can be 1 white car, 2 white car, 3, 4, or the most. Okay, because there's only 5 cars, so the most. Okay, 5 white car. This is the random variable. Okay, the number of white car. Okay, so you list out in set notation is from 0 to 5. Okay, next. I hope now you are a bit better. Okay, can I have, come back here, look at the list. Okay, you see this list, this row. Okay, the one get 1 mark don't answer, which is Farah, Suping, Lydia, and Vanessa. The rest, okay, first come, first serve. Okay, you can type in the chat. I go back to the questions. The number of times a head appear when a coin is tossed 3 times. The number of times a head appear if a coin is tossed 3 times. Okay, write your answer. Okay, in set notation. Okay, write in the chat. Who is the first one get? Okay, I give the 1 mark. Ayo, so fast terperanjat saya. You are ready Okay. Shahira, you got no comma, man. Okay, Shalin, you got no set notation, Okay, Sarah one is correct. 0, 1, 2, 3. Okay, with the set notation and then with the comma in between. So the marks I will give to Sarah. Ayo, you're so fast. Okay, we come back here. Okay, the number of times a head appear. Okay, if you throw the coin 3 times, okay, the number of times for the head appear may be langsung tak ada or till. So it can be 0. Okay, maybe 1 time. Okay, you throw 3 times, 1 time the head appear. So 1, 2, and then the most, because you throw 3 times only Okay, so the most, okay, the number of time for a head appear will be 3 so this is the answer. Okay, but good try, Serene and Shahira. Okay, now number 2. Okay, a ball is taken out from a box which contains a few red and blue balls. Okay, after the color of a ball is recorded, the ball is returned to the box, and this process is repeated 4 times. Okay, if X represents the number of times a red ball is chosen from the box, list all the possible outcome of X in set notation. Remember, set notation. Okay, come on. Who else want to answer? Type in chat. Oh, so fast. My goodness. Siapa tu? I can't read. Ayo, start from the beginning. Okay, Shahira. Okay, Shahira want the marks. Okay, 0, 1, 2, 3, 4. Siti Farah. Okay, also correct. Okay, Ravania also correct. Sherlyn also correct. Okay, all correct. But I will give 1 mark to Shahira. But all the rest are good try. Where? Okay, no Shahira. So I hope so many can answer. I think you all can understand already. Okay, so you see you draw 4 times. So the chances for you to get a red sometimes is none at all. Okay, you do it 4 times already, but you still didn't get a red ball at all, so it can be 0. Number of time to get a red ball. Okay, 0. Okay, 1, 2, 3, and then the most, because you do it 4 times, so the most that you can get the red ball is 4. Okay, so this is the answer. Okay, so this one you don't have to do as homework. Okay, we have gone through it already. Okay, next we want to see this. Okay, as I said just now, you heard about this word already, beginning of the chapters, discrete and continuous. Okay, now you have learned what is a random variable. Random variable must be a numeric value. Okay, it's a variable with a numeric value, must be number. Like just now, this one, okay, win, lose, and draw. This one is not a random variable. Okay, so the rest are the example given here is the random variable. Okay, then for the random variable there are 2 types. Okay, discrete and continuous random variable. So we want to see what is the difference in between these two. Okay, we look at this activity 1 and activity 2. Actually, this activity 1 is the discrete random variable, and then activity 2 is the continuous random variable. Okay. How about here? Since you all can answer, I think it's quite equally. I give all marks lah, huh? Okay, I transfer first. Wait, let me see who. Siti Farah. Okay, not this. Is it this? Yeah. Okay, Siti Farah, Ravania. Siti Farah, Ravania. Serene and Sirania. Serene, Sirania. Okay, now we come back to here. Okay, who didn't answer just now? Okay, take the chance. Okay, same thing. Okay, a coin. Toss a coin 3 times in a row. Okay, record whether you have a head or tail for each toss. Repeat step 2 and step 3. Okay, this one we don't care. Okay, then write all the possible value for the random variable x, which represent the number of head obtained from the 3 tosses. Okay, so I want you to write down the random variable x, okay, which represent the number of head obtained, okay, 3 tosses, okay, in a set notations. Okay, come on. Who's not in the I didn't give the mark yet. Critical, you can write. Vizian can write. Uzaina can write. Shuda, I don't know whether they are here. Sophia, Sonia Sri, Theo, Hanis can write. So let me count. Okay, Vizian. Okay, Hanis. Okay, 0 until 3. Okay, so I think I will accept these 3 only. Okay, Hanis, Weizian, and Ruzaina. I don't know whether this random variable actually is easy or difficult. Okay, look like quite easy. Okay, so here is a 0, 1, 2, or the 3. Okay, because you told us 3 times. Okay, so this is we call it discrete random variable. Okay, okay, look at activity 2. Okay, measure all the height in centimeter of the pupil in your class. Record your result on a piece of paper. Okay, then write the range of the possible value for the random variable y, which represent the height, okay, from the pupils. Okay, may I know, sorry to say that, don't get angry this, may I know who is the shortest in your class? And we don't care whether they take maths or not lah. Who? Kritika?
I'm short, but I don't know who's shorter than me.
Never mind lah. Assume you are the shortest lah. Can but you're
Can.
quite tall what? Let me think. Lydia, are you? What do you think, Lydia? Lydia, are you here? Not to say short, but actually you all are very small size, like maybe Ruzaina, maybe Shahira, all very small size only. Lydia, yeah. Temi, okay, let's say Temi, but Temi is not here, very difficult to get the data. Okay, let's say Lydia lah. Don't get angry, Lydia. What's your height in centimeter? Is it just now? In centimeter. Okay, 156. Okay, and 158. I'm 2 centimeter taller than you. Okay, then who is the tallest in your class? Hanis? Sophia, Siti Farah, I'm not sure. The one always sit at the back one. It look like very tall. Is it? Last time I know, like Megas, not Megasri, Barbina. No teacher, I'm not the tallest in the class. Okay, so, okay, let's say Hanis lah. Hanis the tallest lah. We don't waste the time. Hanis, are you here? 171. Woo. Okay, I ask one more. Hanis, are you taller than 171? Nick, Nick. No, okay, let's say Siti Farah 171 is the tallest. Okay, Lydia, sorry, okay. Let's say the 156 is the shortest, Okay, then. Okay, so 156, okay, 171. Okay, then how we write in the range? Okay, we go to next page, This is how you write. Okay, so you can write in this way. Okay, since we know already, so this A you can replace with a 156, and a B here you can replace with the 171. This is how you write, okay, in the range. Okay, then this is how you write, okay, for the discrete random variable. Okay, this is for continuous random variable. Okay, so this one as your notes. Okay, then these two as the example on your notes. Okay, all this you got to copy. Okay, so random variable that have countable number. You can count 1, 2, 3. Okay, this one is we call it discrete then random variable. Okay, usually taking a value like 0 and positive integer. Then you follow by this example. Okay, if x represent a discrete random variable, hence the possible outcome can be written in set notation. X equals to just now I say, right, the R represent the value inside the set. So this is how you write R double dot and then R equals to 0, 1, 2, 3. Okay, but normally we will not write we will not write the R. Okay, we will normally this one we don't write. Okay, but if they write you got to understand what is the meaning Okay, then for continuous random variable. Okay, random variable that are not integer, okay, but take value that lies in an interval. Okay, so means you're in your inequality are known as continuous random variable, and then you give an example after this. Okay, if y represent a continuous random variables, hence the possible outcomes can be written as y. Okay, y is represent the set. Okay, and then this y is the value. Okay, y is the pupil's height in centimeter, the small y. Okay, then you put in an inequality. Okay, so now I hope you understand what is the meaning of discrete and continuous random variable already. Can we look at this example? Okay, write down all the possible outcome in the set notation for each of the following events. Determine whether the event is a discrete or continuous. Okay, explain it. Okay, a fair dice is thrown 3 times. Thrown 3 times. Given x is a random variable which shall represent the number of times to get the 4. Okay, if you throw it 3 times, okay, the most number of time you can get 4 is 3. Okay, therefore you end at 3. Okay, it can be not one time at all. You can get the number 4. Okay, so it start with 0, 1, 2, 3. Okay, so this is very obvious. Okay, this is countable number, so this is a discrete. Okay, because its value can be counted. Okay, countable number. Okay, number B. Okay, x is a random variable which represent the time taken by a pupil to wait for his bus at the bus stop. Okay, the range of time taken by the pupil is between 5 to 55 minutes. Okay, so you write out in this way. Okay, x, okay, and then equals small x, double dot, x is the time in minutes. For the continuous random variable, this one normally you got to write. Okay, where, okay, or you put comma. Okay, the small x is in between 5 to 55, including 5 and 55 is between, or should be okay, sorry, is between, so should be no equal sign if in between. But when you learn normal distribution, got equal sign, no equal sign, the same thing one. Okay, for normal distributions, the inequality with equal sign or no equal sign not affect anything on the result one. Okay, so the event is an continuous random variable because its value is an interval. Okay, lies in an interval from 5 to 55. Okay, this is how you explain it lah. Okay, so this one you do as your homework. Thing is either with discrete or the continuous. Okay, after this, then we will see into a discrete only. Okay, we'll see into discrete random variable. So these are actually prepared for you to learn a binomial distribution afterwards. Okay, so what is this? The meaning of a probability distribution. Okay, here this subtopic we want to see what is the meaning of this probability distributions. Okay, you have learned probability. I don't know when. I think the word form or what. Okay. You can recall all this. You can recall all this. Okay, I give you some time to go through. I go and get water and come. Okay, so you use this time to go through this, recall all this. Okay, come back. Okay, so I hope you still remember all this. Okay, it's a very important that you know the for probability. Okay, if the question asks you what is the probability, your answer cannot be more than 1. Your answer also cannot be negative. Okay, probability is in between the and including 0 to 1. Okay, if your probability is 0 means that event is not possible to happen at all. Okay, and if your probability is 1 means it confirm it will happen. Okay, then this one is a complement no huh? I hope you still remember all this lah. Now we go through this example Prepare 5 pieces of a square paper. Okay, each paper you write a number 1 to 5. Okay, put the 5 pieces of paper in a small box. So every time you draw one. Okay, take a piece of paper from the box at random and record the number of them. Return the paper in the box before choosing another piece. The process is repeated twice, so you do it 2 times. Okay, so first time and second time. Okay, they draw out in a 3 diagram, same like just now. You know, you beginning of the chapters, we have the basketball matches. Okay, so we have a win, loss, and the draw. Okay, I also doing in the 3 diagram. Okay, so if X is the number of time of getting an odd number, so now they are concentrating on an odd number. Okay, X is the event of a number of time of getting an odd number. Okay, so you see 1 until 5. Okay, you have how many odd number? 1, 2, 3, 3 odd number. Okay, so mean out of the 5 number, okay, 3 number are odd number. So this G is actually means getting odd number. This G, okay, means getting odd number. Okay, so G prime means the complement of it, so not getting odd number or getting even number, not getting odd number. So the probability for you to get odd number is 3 over 5 because out of the 5 number, 3 number are odd. Okay, and then the probability for you to get even number is 2 over 5. Okay, remember 3 diagram, every branch of it must add up with 1. So 3 over 5 plus 2 over 5 is 1. Okay, then you continue. Same like just now, how you list out. Okay, so this one also it can be G and then G prime. This one also the same. Okay, it can be G or G prime. Okay, so you list out the outcome. This is a GG, this is a GG prime, this is a G prime G, and then this is a G prime G prime. Okay, now we come back to this random variable. Okay, discrete random variable. Okay, X is the number of time of getting odd number. Okay, so X is what? You can list out. Same thing, it can be 0. Okay, none at all. Okay, because you do it 2 times, so the most is 2. Okay, so it can be 1 also. So this is the possible value for the X. Okay, so we analyze we continue here. Okay, if the outcome is a GG, okay, X is equal to R. R is the one inside here. It can be 0, 1, or 2 long. The R here, it can be 0, 1, or 2. Okay, so if the case is GG, so it's 2 long, means what's the meaning? 2 times. You are getting an
X is 2.
Sorry? Someone say something? No, okay, so GG means first time is odd, second time is odd. So how many times? Okay, you getting an odd number 2 times. So you list out here X is equal to 2. Okay, Then if G prime is one time, okay, you get an odd number. G prime G is also one time, you get an odd number. G prime means not an odd number, not an odd number, so 0 time, you get an odd number. Okay, so you continue here. They ask to find the P. P means the probability. Okay, what is the probability for you to get GG? Okay, so if you complete the this tree diagram, so here same thing 3/5 to get an odd number, 2/5 not odd number. Here also same thing, 3/5, then here is 2/5. Okay, so if you are following this branch GG, so it's 3/5 times 3/5. So this is the answer. Okay, you are following this branch, so it's 3/5 times 2/5. I hope you still remember all this. This is you have learned in modern maths maybe last year. Okay, so this is 6/25. Okay, G prime G is here. G prime G. So 2/5, 3/5, same thing. 6/25. Okay, lastly, okay, G prime and G prime is 2/5 and 2/5. 5 and 2/5. Okay, 4. Okay, so after you do this, one thing is very important for you to double check your answer is how. Okay, you just add up all the possible outcome, the probability. Okay, if you didn't get one, means you didn't list out all or you have made mistakes somewhere. If you get one, most probably your answer is correct. Okay, so 9/25 plus 6/25 plus 6/25 plus 4/25. Okay, you just use 9 plus 6 plus 6 plus 4. This is 10. This is 15, 25. 25/25 is 1. Okay, so most likely your answer is correct. Okay, so you see, okay, from the tree diagram, find the probability for each value of the x. This one I done. Okay, the total probability, as I said just now, you add up all, then you get 1. Okay. Okay, we come to a conclusions. Okay, it shows that the possible value of x is 0, 1, and 2. Okay, this one you know already. Each of these number represent the event from the sample space. Okay, this one also I list out for you, the sample space. The probability for each event can be summarized in the probability distribution table for x as shown in the table on the side. If they ask for a table, okay, probability distribution table, this is how you write the table. Okay, the x you can take what value just now we say you can take 0, 1, or 2. So you list out 0, 1, and the 2 here. Okay, then for the probability, we go back here. Okay, when x is 0, when x is 0, this is the probability 4/25. 4/25. Okay, when x is 1, okay, come. When x is 1 got 2, so 1, 2. Okay, you add up these 2. Okay, so 6 and 6, so it's 12/25. Okay, lastly, okay, when x is 2, okay, this one, so 9/25. Okay, okay, this is how you make the table of the probability distributions. Okay. This one, if you want to copy, you can copy in, but not necessarily you need to copy. But I want you to understand. Okay, this is same like your probability lah. If x is an discrete random variable with the value r1 until rn, and their respectively probability are this, then okay, submission means the total probability is equal to 1. This one is very I mean the basic knowledge, okay, the total of every possible outcome of the probability is 1. Okay, and then for probability, you know lah, cannot be negative. Okay, so it's a 0 or greater than 0. Okay, this one you no need to copy also, can. Okay, just need to understand. Okay, now we come to see one more example. Complicated. It is more and more complicated. Okay, you need to analyze a bit. Okay, 2 fair dice are tossed together 3 times. Okay, let x be a discrete random variable for getting 7 from the sum of the number on the 2 dice. Okay, like example, you try to 1 time like this, 4 and the 6. Okay, the sum of the number on the two dice, this is 10. But the x is the random variable of want to get 7. Okay, so I hope you understand the situation. Two dice is throw together, then you want to throw 3 times. Okay, so may I know what is the x in the set notation? You throw it 3 times. Okay, so the most number of time that you can get 7 is 3 long. Okay, and then it can be 0, 1, and 2. Okay, so x is this. Okay, draw a tree diagram to represent all the possible outcome of the x. Okay, but before that, we analyze a bit. This is okay. First die, it can be get the sum. 1 plus 1 is 2 long. 1 plus 2 is 3 long. 1 plus 3 is 4 long. 1 plus 4 is 5. 1 plus 5 is 6. 1 plus 6 is 7. Okay, so if the first die is 1 to 6, the second die is 1, is only one possibility. So when the first die is 1, when the first die is 6, the second die is 1. Okay, there's only one possibility. Okay, I mean one outcome only will give you the sum is 7. Okay, you look at the second row, the same thing, only 1. Okay, outcome will give you the sum is 7. Okay, third row, the same thing. Fourth row, the same thing. Fifth row, the same thing. Okay, sixth row is same thing. Okay, so what is the probability for you to get the sum is 7? Okay, so 1, 2, 3, 4, 5, 6. Okay,
Teacher, are you talking? Hello. No, teacher.
She left. No, can everybody hear me?
Yeah, I can.
No, can hear me.
Yeah.
Thank God. Yeah, I was talking for too long.
Just now she wasn't talking, right?
I went to toilet, so I'm not sure. I came back, she wasn't talking at all.
Aiyo, okay, can hear me or not? Someone had to on the mic.
Can.
Okay, what's
Yeah.
happening just now? Where do I stop actually? Just now is Siti Farah, you call me, huh?
Yes, I call you.
Okay,
You
but I
stop
can't
at
hear you.
example 3.
I stop at example
3.
3, alamak. Then I'm talking to myself so long, Okay, example 3, I finish or not?
No, I think until B only.
Until B. Okay, do you know how to list the possible outcome already? Okay, I have to share screen wait for a while. Okay, now it's already 29. I don't know whether the video record everything or not. Because I have a next class to go. You all just feedback to me, okay? Afterwards, okay. I have to stop the class now, okay? And then we will contact each other through the WhatsApp lah, huh? Okay, I started. I don't know. I stopped recording. I don't know whether they